Okay, so good morning, everyone. This is our lecture, part 3 on climate. Okay, so we'll be talking about Milankovitch cycles and ice ages, uh, ancient sea level changes, greenhouse warming, and El Nino and global climate change through time. So again, whatever we don't finish today, we'll be continuing on Thursday face to face. Okay, so in the recent news, at least malamang narinig niyo na yung problem with regard to sea level rise. And this is a problem that's not only being faced by Philippines, but most of coastal communities around the world. Yung more recent na nag-viral yung address ng Tuvalu president sa rest of the globe tungkol sa kung ano dapat yung gawin kasi yung island nation niya is slowly being eaten away by the sea. Okay? So hindi naman sea literally being eaten pero sea level changes is basically sinking their land. So, let's look at ano ba yung trend ng sea level. So, as we can see, this is sea level measurements from 23 tide gauges uh, recorded in geologically stable environments. When we say geologically stable environments, these are areas na hindi nag-uplift, umaangat yung lupa because of tectonic processes, hindi siya nangyayari. And at the same time, hindi rin siya nagsisink because of other tectonic processes like rifting, for example. In the case of the Philippines, for example, Northern Philippines, yung Batanes group of islands, those are continuously being uplifted because of volcanism as well as compression. So nasa subduction zone tayo, so nako-compress siya. And at the same time, meron ka ring areas like sa Pilipinas. Wala sa Pilipinas yung rifting, pero meron for example sa Kenya, yung example ng Great Rift Valley sa Africa. So this is an area naman na baliktad. So since naghihiwala yung plate natin, yung gitnang area, bumabagsak siya year on year. Okay, so the geologically stable areas or environments has neither of those processes. No uplift, no sinking. Okay, and in those areas, yung changes sa sea level is essentially because of sea level rise, sea level change rather. And as we can see from this graph, from 1900s, yung sea level natin on those areas has been consistently rising. So pataas ng pataas. And if we zoom in dito sa mas more recent na past, 1995, 1994 to 2020, it has been rising for about 3.3 millimeters per year. So, since pinanganak ko 94. So, since 94 to the present, roughly nag-rise na yung sea by about 90 millimeters. That's almost 1 meter. So, 1 meter is basically from ground to siguro my waist. So, half a person na yung sea level change. And this is environment that's supposedly stable. Okay? I mean, for areas that's relatively stable. Yung distribution ng sea level rise is also not consistent or not constant throughout the globe. Sa equators, generally, mas mataas yung sea level rise just because of the shape of the Earth compared to sa poles natin. So, itong 3.3 millimeters per year na to, this is average globally. In some areas, the sea level rise is even faster. Okay, so for the last 2 million years, yung 200 million years rather, yung ating sea level rise is largely a function of ice ages. Right? So, you can think of it this way. Yung, I think better ito, pakita ko muna ito. Babalikan natin mamaya. So, in the long term or in the recent millions of years, yung nag-affect ng ating sea level rise is actually yung abundance or lack thereof ng glaciers and ice caps. If you look at this graph at present, 97% of water, all water, is locked in sa oceans. Only 3% is fresh water. Pero of that 3%, 79% are held in ice caps and glaciers. So majority ng fresh water is basically locked sa ice caps and glaciers natin. If this starts melting, then you can see na yung fraction ng water in the ocean even gets even more. Okay? And for example, if we look at yung last glacial episode, itong black line here, pinapakita niya yung change in so roughly, this was roughly 20,000 years. So ito yun, roughly 20,000 years, yung sea level was way below what we have now. So this is the mean sea level at present. And as you can see, yung sea level dati, around 20,000 years ago, last glacial maximum, we can see that the sea level was about 150 or 130 meters below current sea level. So basically, yung coastline then was much different, was very different compared to what we have today. So mas mababa siya, more land is available. Ito rin yung periods na we have land bridges connecting some of the continents just because yung sea level natin ay sobrang baba. At the same time, because of glaciers, because of the presence of glaciers. At the same time, kapag naman natutunaw yung glaciers natin, it provides more water aside from the ocean heating up and expanding. It provides more water so that yung sea level natin increases. Yeah. And itong trend na pinakita ko kanina, yung increasing sea level, is correlative to what we see sa glaciers. So as more and more glaciers, as the volume of glaciers decreases, the sea level increases. Right? That has been true for the last millions of years. Of course, there are other factors which affect yung sea level locally. For example, as I mentioned before, yung uplift. If the area is being compressed, for example, then it's continuously being uplifted. And yung uplift na yon sa area na yon causes sea level to actually fall. Diba? Kung mayroon ka namang areas, kunwari, Kamanava area, Kamanava is sinking because of groundwater, groundwater, we'll talk about it later, pero groundwater extraction. So, under the land, you have, under yung sediments natin, we have water, and kapag mayroon kang poso sa bahay, mayroon ka nung pang-extract ng fresh water, if you pump that out, basically yung space where originally may tubig gets compressed. So bumababa yung lupa. Yeah. So in those areas naman na sinking, sea level is rising much faster. So there are local factors. Pero globally, yung nagko-control ng climate, ng sea level natin, at least for the last 200 million years, is actually the abundance of glaciers. Okay? Yeah. So what causes sea level changes? Of course, yung presence or abundance ng terrestrial water storage as reservoirs, natural reservoirs. Kapag kunwari nagda-dam tayo, malamang, of course, yung available fresh water that goes into the sea, transmitted by the rivers is much less. Kapag mayroon kang sediments that are able to hold the fresh water on ground. So groundwater, we call this the groundwater. Then the more groundwater you have, the less water it is available for the sea. Ganun din yung story ng glaciers, etc. Bukod pa din sa amount ng water supplied by the glaciers, yung warming of the oceans causes also the water to expand. And as the water expand, volume-wise, lumalaki yung area na tinocover nila. So it's a compounded effect, for example, with what we are experiencing today. Today, what we are experiencing is rising global temperatures. The rising global temperature melts more and more of the ice of the glaciers that we have, providing more fresh water towards the sea, which flows towards the sea. And at the same time, yung ocean natin expands because of the heat, because of heat. So yung compound effects na yun causes sea level change to rise faster than historical average. Yan. Okay. And so short-term and periodic changes are, of course, tides, meteorological and oceanographic fluctuations, seasonal variations, and earthquakes. So locally, kunwari, pag may bagyo, you may have heard of the term dito? You may have heard of the storm surges. So during every time na may typhoons tayo, yung typhoons brings with it yung very tall waves, which we refer to as storm surges. So this causes short-term sea level change. But in the long term, in at least for the last millions of years, ang nag-affect ng sea level natin is glaciers and ice caps. Again, because of this graph. Okay? Ayan. So, and throughout the history, we've seen binalikan ko to, we've seen the effect of of drastic sea level changes because of changing climate doon sa ating coastal communities, sa ating areas. Hindi lang coastal communities, in settled areas rather, by humans, for example. So, for today, we'll first look at ano yung nagko-cause in the first place ng glaciation. Bakit cyclical or cyclical? Bakit cyclical yung itsura ng curves natin for the glaciation? So, this was thousands of years ago. So, obviously, wala tayong direct contribution dito as humans. Itong thousands of years ago, wala pang industrialization ito. But as you can see, cyclical na even then yung sea level and as a function of glaciers. So, ano yung nagko-cause nitong cyclicity nitong glaciers, abundance ng glaciers. So, the number one, or now we know that the amount of glaciers present in Earth is largely controlled by what we call the Milankovitch cycles. So this is, at least in the recent millions of years lang. This is not true for the whole history of the Earth. Pero for the last 200 million years, since the breakup of Pangaea, ito yung mukhang nag-affect ng ating global climate. So, orbital theory of ice changes, regular changes in the shape of Earth's orbit and Earth-Sun geometry results to direct changes sa abundance ng ice sa Earth. This was first suggested by Adler and later James Prohl, pero it was quantified by Milutin Milankovitch. He is a mathematician in the 20th century, and basically what he told us is that based sa shape ng orbit ng Earth, and at the same time yung rotation ng Earth, yung changes na yon, eccentricity, tilt or obliquity, and precession ng ating Earth's orbit directly affects yung ating climate. Okay, so this describes the collective effects of changes in the Earth's movement upon its climate. So first, iisa-isahin natin itong mga processes na to. First is eccentricity. So eccentricity, this is the measure of the departure of the Earth's elliptical orbit from circularity. If you have no eccentricity, if you have a circular orbit, it's like this. If you have an eccentricity like this of 0.5 eccentricity, ito yung shape niya. The cycle of this one is every 100,000 years. So every 100,000 years, from something more eccentric like this, or no eccentricity like this, it becomes more and more eccentric like this. Okay? This is 0.5. Yung eccentricity natin is just 0.017. So mas maliit naman. Pero ano yung effect niya? If you imagine, what we have now is something like this. Okay? What we have now is something like this, and what we have here is basically an interglacial period. Okay? Interglacial period kasi this is the time when yung part of the Earth is experiencing summer kasi sobrang lapit niya sa Earth, sobrang lapit niya sa Sun, so yung amount ng sunlight that it receives is much higher. Pag nandito ka naman sa kabila, the Earth is experiencing winter, or a portion of the Earth na nakatutok dito is experiencing winter kasi siya naman yung nakaka-experience siya naman yung nakaka-receive ng much less amount of sunlight. So, summer kapag nandito, winter kapag nandito away from the sun. Okay? Paano kapag gantong circular? Pag walang eccentricity, yung ating climate yung ating seasons rather, yung ating seasons is less pronounced. Halos walang difference yung temperature ng summer, na yung high temperature during summer and low temperature during winter. Halos walang change. Halos walang change means it's cold all year long. Okay? And because of that, glaciers can move. And yung effect ng glacier is that land, yung lupa, continents, yung lupa natin, it generally reflects sunlight. Right? In comparison, yung dagat natin generally absorbs sunlight, heat. Okay? So the more land you have, the more sunlight is reflected. Ano yung mas better na reflector ng sunlight? Ice. Ice reflects more sunlight, even more sunlight than just barren land. So the more glaciers you have, the more sunlight is reflected back, the less heat is trapped on Earth. So lalong lalamig. So this is a compounding effect. This has a compounding effect rather. So if yung seasons natin has no drastic difference, winter versus summer, uh, ice starts to grow. Okay? So ngayon, here, in this particular case, what we have is a very warm summer that melts any ice or much of the ice that gets formed during winter. Pero pag nandito ka sa cycle na to, halos walang difference yung summer and winter. So yung ice na na-form ng winter will not necessarily be melted during summer. Right? And at the same time, yung ice na yon reflects more sunlight so that yung heat sa Earth is less and therefore the glacier can start growing again. And compounding effect, mag-grow lang siya na mag-grow, reflecting more and more sunlight until eventually we have a glacial period. Okay? So that's eccentricity. One more is another cycle is yung axial tilt ng Earth's orbit, rotational axis, or what we call the obliquity. So, minsan, nag-shift to siya from 22.1 degrees to 24.5 degrees, roughly around 23.44 degrees Celsius. And again, yung ice natin na usually nasa poles, nasa north and south poles. So this has also direct effects sa amount ng sunlight that gets reflected back. So the obliquity is the angle between an object's rotational axis and a line perpendicular to the Earth's orbital plane. Yeah. Next one is axial precession or greater every 26,000 years. This is the gradual shift in the orientation of the Earth's axis. Yeah. So, um, yung tilt natin is ganyan siya, di ba? Tapos umiikot yung Earth natin. Yung precession naman is yung how the Earth is wobbling. So, pag nagwo-wobble lang siya na ganyan, or pwede siya mag-wobble na mas malala, mas malaki yung ikot niya. Okay? Yun naman ang tatawag nating axial precession. Yan. And then meron pang upsidal precession every 20,000 years. So ito yung pinapakita niya eccentricity, pero yung location ng eccentric nung orbit niya also changes with time. Yeah. So upsidal precession every 21,000 years. So, ito yung sinasabi ko kanina, of these three, yung pinaka nakaka-affect sa atin, long term, pero pinaka-profound yung effect is of course yung eccentricity yung eccentricity. So, during low eccentricity in the Earth's orbit, we have what we call a glacial period because of the process I've mentioned before. Basically, you have less contrast between seasons, and therefore yung yung glacier na grow during winter will not be melted during summer, and it can continue on reflecting more sunlight, which produces a cooler environment. Okay? So paulit no compounding effect until eventually nasa glacial period ka na. Kapag naman mataas yung eccentricity natin, you have more pronounced winters, mas malamig yung winters, mas mainit yung summer, and ang consequence nun is that any glacier that forms here will largely be melted during this time. So you have interglacial period, okay, a generally warm period. Yeah. So research showed that the 100,000 year eccentricity cycle is the dominant process for the ice age cycles during the quaternary glaciation from 2.5 million years. So over the last few million years, yung eccentricity has a direct effect uh, sa ating glacial period, sa glacial periodicity sa Earth. Okay? Ito yung 100,000 cycle, for example, showing us yung ano ba to? Carbonate. This is anyway, ang pinapakita lang naman ito is yung so nandito tayo sa within the 100,000 year cycle. Okay? May papanood ako sa inyong documentary on the Sahara Desert. Did you know na Sahara Desert around 2.5 billion years ago was covered by the sea, by ocean. So dati ocean yun siya, and then little by little na-transform siya into actually a forest. Okay? And itong forest, yung transition niya from forest to desert is a direct effect din ng Milankovitch cycle. Panoorin nyo na lang. I-upload ko yung link sa email natin. Okay? Maganda siyang documentary on how Milankovitch cycles directly affect. I think that one is ito naman, yung 41-year cycle, yung nakaka-affect sa kanya. Yan. So an ice age, or more precisely glacial age, is a generic geological period of long-term reduction in the temperature of the Earth's surface and atmosphere, and it results to the presence or expansion of continental ice, polar ice sheets, and alpine glaciers. Continental ice sheets, ito yung nasa Greenland at saka nasa Greenland sa north, sa south, ito yung nasa Antarctica. Okay, yan yung continental ice sheets. In general, yung glaciers natin, they grow sa lupa. Okay, kasi kailangan nila ng root, kumbaga. Okay? They can expand sa sea, pero hindi sila stable sa sea just because yung dagat natin ay water. So, they slowly get dissolved doon kung tumaas yung temperature. So, much of the ice is actually locked in as ice sheets. In areas na sobrang taas, mountains na sobrang taas, they can also host, of course, what we call alpine glaciers. So, ito yung glaciers na nasa taas ng mga bundok. Okay? So, glacial periods are colder periods during ice ages. In general, because you have less ice and also cooler sea level drops due to the removal of large volumes of water. On the other hand, interglacial periods are warmer periods. So warmer periods means less ice and therefore more water and higher sea level. So here we have yung temperature change. This is 0 is present. So ito yung present natin. So when it is much cooler, yung amount ng ice natin is much more. Okay? Balik na to. So this is low and this is high ice volume. So kapag mas malamig, pag mas malamig, mas mataas yung volume ng ice. And kapag mas mainit, yung volume ng ice naman natin is much lower. Okay? So very naman siya, intuitive. So ito yung ating glacial periods. Ito yung ating glacial periods and ating interglacial period. So actually, ngayon tayo ay nasa interglacial period. Ngayon, so darating yung time na lalamig yung buong mundo just because of the eccentricity. Dito natin tingnan yung eccentricity. So, kung titingnan natin, andito tayo ngayon sa 0. Okay? Dito tayo sa 0. And yung last peak was roughly around 100,000 years ago. And if you compound that, if you look back, yun din. Before that, it was 100,000 years. Before that, it was roughly 100,000 years. Another 100,000 years, so on and so forth. So ito yung direct effect ng Earth's eccentricity sa amount ng glaciers that we have. Okay? Yan. So, an ice age, or more precise, ito yung ice ages nga. And this was during the last glacial maximum, around 18,000 years. Glaciers basically covered yung northern hemisphere natin, both sa continents and as well as the sea. Sa Antarctica, if you look at yung sa Antarctica, yung ice natin was also covering ito, yung mismong continent of Antarctica, of course, and it extended further out dun sa labas sa sea ice. Ito naman yung modern day glaciers natin. It gets less and less every year. But in general, ganito yung itsura niya. So, wala na yung glaciers sa North America, sa sa Europe, Europe, yan. And sa Antarctica, halos confined na lang sa continent mismo yung glaciers. Yan. Tingnan natin. So, if we are here sa Siberia, yung wala, basically covered in ice. If you look at this one, this is Sweden and Norway. Ngayon ay Sweden and Norway. I think Norway ito na dito. Sweden, Norway, and Denmark. So itong area na to, yan, covered sila in ice. Great Britain was covered in ice. Ngayon, hindi na sila covered in ice, of course. Yan. So ito yung modern day extent natin. Okay? Ito na yung itsura niya. Because of interglacial period. Nandito tayo ngayon. Naturally, nasa interglacial period tayo. Okay? So, this is for the past 2.5 million years. Okay? But take note na during other periods sa Earth, hindi laging function ng eccentricity, ng Milankovitch cycles anyway. Hindi laging effect ng Milankovitch cycles yung ating glacial periods. For example, we have during the Proterozoic nga yung Huronian glaciation, which was largely due to the fact na meron kang volcanism that was extensive. And itong extensive volcanism, or possibly yung volcanism na yun, which was very extensive, produced more and more ash, which reflected, at least one hypothesis is that it reflected sunlight, which then resulted to the cooling down of Earth and then the compounding effect. Ayan. And if we look at, ito yung current ice age natin, ito yung mga in the past, relatively mas maliit na mas maiksi na yung ice ages natin ngayon compared, for example, sa Huronian glaciation, which lasted for 300 million years. And, kung anong itsura ng Earth back then, you can just look at Neptune, for example, the blue planet. So everything is covered with ice. O kaya yung Saturn, yung Jupiter moons, meron din silang mga glacial worlds doon. Okay, so how do we know that there were ice ages in the past or glacial periods in the past? Of course, through geologic, chemical, and paleontological evidence. Geologic evidence such as rock scouring and scratching, glacial moraines, terrains like drumlins, valley cutting, etc. Siguro, long story short, as I mentioned before, yung Sweden, Norway, Great Britain, these areas were largely covered in ice during the last glacial maximum. And some of the land features that we see there today, we can directly link to the last glacial period. Yeah. So things like yung glacial moraines, drumlins, yung rocks natin. So the ice is moving and it's solid. So it basically grinds yung lupa natin, tinatanggal niya. Anything, para siyang ano ba? Snow sa Pilipinas. Para siyang bulldozer. So yung bulldozer, kahit na anong nasa daan niya, tinatanggal niya na. And at the same time, yung ground natin gets scratched. So rock scouring and scratching. In terms of chemical indicators, meron tayo ng ratio of isotopes in delta O18, for example. So delta O18 measures yung abundance ng delta 16 ng oxygen isotope 16 versus oxygen isotope 18, which is directly affected by the climate. I mean, yung abundance nila sa atmosphere is directly affected by amount ng rainfall and also amount ng glaciers. We won't go into detail, pero that is how we know na based on isotopes, we can tell, for example, delta O18 niya, how much is it snowing and how much colder was it, or how much drier pala was it. And then, of course, paleontological evidence. if we have woolly mammoths, woolly mammoths, for example, distributed all the way dito sa North America and at the same time sa Europe, then you know that you're in a glacial period. Okay? If woolly mammoths were absent or if there are no ano ba to? Or depende sa organism basically na nabubuhay at that time. Yung remains nila can of course give us an idea kung anong climate yung meron nun. For example, during the last glacial maximum around 12,000 and Pleistocene, during the Pleistocene, because of the glacial maximum, there was a strait, the Bering Strait. There was a land connecting yung North America with the rest of Eurasia. And we know that there was a connection at that time kasi we see animals na na native endemic lang dito sa dito sa Eurasia suddenly appearing sa North America sometime during that period. Okay? And vice versa. Okay? Ganun din, for example, land bridges connecting yung Philippines to the rest of Asia, Asia being Indonesia, Indonesia and the Indochina block, yung Indochina microcontinent. So ito yung connections natin during the last glacial maximum. For example, yung large species na meron tayo sa Pilipinas, like Stegodon, meron tayo dating rhinoceros. These species were there or traveled to Philippines through these land bridges. Okay? Not humans, not humans. This is 65,000 years ago. So if you look at Australia, for example, this is the present-day shoreline, itong line na pinapakita niya dito. But 65,000 years ago, the shoreline was here, was much lower because of the glacial maximum. So nakakonect siya sa New Guinea, for example. Okay? Hindi naman completely. For example, sa Pilipinas, meron kang very deep gouges separating Palawan from Mindoro. Yung Central Philippines din natin, meron din diyang deep structures na hindi na expose and therefore block yung rest of Luzon from this area. Yung Northern Luzon, however, was connected din sa other mas medyo connected din sa ibang areas naman sa north naman ng Asia. Ayan. So ano yung other causes for ice ages? Sabi ko kanina, and ano yung effects niya? So yung effect in the last millions of years, it was largely driven by the Milankovitch cycles. Pero, as I mentioned before, hindi yun laging true. So millions of years ago, it's always a function of the albedo. Okay? Albedo is how much of the sunlight is reflected back to space. Kapag mas marami yung amount ng sunlight that is reflected back in space, less heat is trapped within Earth and therefore, generally, meron kang glaciation na nangyayari. So, for example, position of the continents. So, position of the continents affects the albedo. The more land you have, for example, during the age of the dinosaurs, the temperature then was much higher. Let's look at here. Nilikan natin yung iba, like earlier slides. Yeah, that was roughly 200 million years, 200 million years ago. If you look at 200 million years ago, yung temperature at that time, yung sea level at that time, was generally higher than today. Mas mataas pa siya than today. Mataas than today. And the reason why it's much higher then is that sobrang init kasi at that period. Sobrang init that period kasi during si Pangea, isang piece lang siya. All the continents were basically merged into one. So that ito lang yung area that is able to reflect sunlight. Okay? The rest is sea, covered by the sea, and yung sea natin absorbs heat. Okay? So low albedo means low albedo means more heat is trapped within Earth, and this produces a warm climate. Okay? So ngayon naman, for example, what we have is less ice. So because we have less ice, we also have less albedo, less amount of sunlight that gets reflected back. Okay? Ito yung ngayon, pero before, yung position of continents directly affects yung amount ng albedo, amount ng sunlight that gets reflected, and therefore yung temperature ng Earth. Next is fluctuation in ocean currents. So the heat, sabi natin yung sea, yung dagat natin absorbs the heat and hindi naman to naiiwan lang sa isang area. Through ocean circulation, yung heat is redistributed and this affects yung amount ng sea ice that is present in an area. And again, the amount of sea ice will affect yung amount ng albedo. Next factor is volcanism. Itong volcanism medyo compounded, medyo iba yung, depende kung ano yung effect niya. Okay? For example, si Pinatubo. Nung nag-erupt si Pinatubo, it brought in ash sa stratosphere, so surrounding, covering yung Earth basically. And yung ash na yon is, ang effect niya, reflects sunlight. Okay? Reflects sunlight and therefore higher albedo and therefore cooler temperature. But if we have volcanoes spewing carbon dioxide, okay? Carbon dioxide is a natural greenhouse gas, and greenhouse gas keeps the sun's temperature keeps the sun's rays within the Earth and therefore heating yung ating environment. So medyo depende kung ano yung effect niya. But anyway, volcanism can have a cooling effect. In case of ash covering the stratosphere or carbon dioxide, it can have a warming effect. Okay? Depende. And then, of course, we've been talking a lot about how the Earth affect or interacts with the amount of sunlight. But of course, yung input from the sun is another factor. If, for example, nakatutok tayo sa sunspot being wala siyang less yung amount ng, wala siya basically nilalabas na rays, dun sa areas na yon. So you have less heat input from the sun and therefore cooler Earth. Yeah. And then other minor effects like uplift of Tibetan Plateau, which produces more snow and therefore more reflection, and as well as changes in the Earth's atmosphere, yun nga, yung abundance ng greenhouse gases. Okay? Ano yung effect niya sa humans? Throughout the history, we've seen the effect of global climate changes, sudden global climate changes, especially in the form of great floods. Okay? Great flooding, for example, during periods of drastic changes in the climate, suddenly, yung rush ng glacial meltwaters, for example, can result to flooding events which have been recorded throughout the history of the Earth. For example, the Great Flood is used to describe the central event in any of several versions of the flood myth, whether historically or accurate or mythological. The fact is, this has been recorded across multiple civilizations. So in the past, this must have occurred. For example, this is a picture of the Great Flood. The deluge, ito yung depiction ng deluge na related sa Noah's Ark. Pero actually, yung Noah's Ark was based on the Epic of Gilgamesh from another civilization, which was in itself adapted from another civilization's story of a great flood, yung Akkadian Atrahasis. Anyway, pinapakita ko dito, ito yung tablet depicting yung or telling the Epic of Gilgamesh. So, ganyan yung ancient, ito yung cuneiform writing, ganyan yung tsura ng cuneiform writing. Yan. So, yung Noah's Ark natin is was actually depicted or was actually an adaptation of the Epic of Gilgamesh, which is on itself, depiction of Atrahasis, the Akkadian story. Okay, and geologically speaking, we have evidence for the flooding event that happened at that time. But it's not necessarily, or anyway, baka sabihin yung heretic ako, pero this is a natural phenomenon. Right? This was a natural phenomenon which occurred around 7,000 years ago. So ano nangyari exactly at that time? 7,000 years ago. Back then, the Black Sea, this is the Black Sea, again, this one, was much smaller and it was cut off from the Mediterranean by the Bosphorus Strait. Surrounding yung Black Sea is a flat, fertile ground. Flat meaning yung change in topography is very, very gentle. Okay? Para siyang isang mahabang Pampanga Basin. And as you know, any flooding event, kahit na konti lang yung flooding event, since it's a flat area, it affects the whole expanse. Okay? And approximately 7,500 years ago, it was the warmest interval of the Holocene. And because of the warm climate, suddenly you have glaciers melting, plus plus the seawater expanding. So you have a rising sea level rushing through the Bosphorus Strait. So you can think of it as a dam. Yung Bosphorus Strait natin dati, nakadam siya so that yung any rise in the Mediterranean Sea is prevented from rushing towards the Black Sea. Pero this is a dam, natural dam, so any breach in that dam will have a drastic effect. So imagine you have here the Bosphorus Strait, and then suddenly in the breach yung dam, and once the dam has been breached, yung seawater ng Mediterranean Sea came overflowing dito sa Black Sea. Okay? And since the area surrounding the Black Sea is relatively flat, maraming malaki yung area na na-affect ng flooding event na yon. Roughly 7,000 years ago. But this is not the only prehistoric flood. Zanclean flood, for example, around 5.3 million years ago, is thought to have involved sea level rise changing by 10 meters per day. 10 meters per day. So 10 meters is basically yung buong mixed building. So imagine your sea level increasing suddenly because of that. And then you also have here, ayan, this is what the topography of the Europe, Northern Africa area would have looked like during the Zanclean flood, roughly 5.3 million years ago. This is another great deluge. Okay? Wala pang tao ng deluge na to. So, baka naman hindi natin gawa. Okay? Another one, 15 to 13,000 years ago, is the Missoula floods. Ganun din, it was an outburst of floodwaters that swept periodically across eastern Washington and down the Columbia River Gorge because of melting seawater. More recently, we also have that problem. Usually, this is the spring floods sa areas na nasa temperate climate. So you have here temperate meaning yung may winter, summer, ganyan. So every winter you have glaciers that are growing. And then during spring, as the temperature increases, yung meltwater basically ng glaciers starts flooding these areas. This is glaciers, directly related to glaciers. But of course, meron ka ring storms. And in more recent stories, for example, Germany, 2021, they experienced the worst flooding in over generations, which claimed 180 lives. Pakistan, this was due to changing monsoon rains. It claimed 53 lives, and hindi na natin kailangan lumayo. Nung Odette, just 2 years ago, 2021, this is a picture of Negros covering yung area, basically covered in flood water, yung malaking area sa Negros, claiming 410 lives. Ganun din yung sa Ondoy, 921 lives naman during 2009. Kung naalala niyo pa si Ondoy. Yan. So ito naman, this is not directly related to floodwaters. This is directly related to storms, pero yung storms na to is still a function or still a direct effect of the rising sea level. So rising sea level means you have more water that gets pushed by the storm during cataclysmic or during those events, during pag sobrang lakas ng sea, pag sobrang lakas ng sobrang bilis rather ng wind natin, it can push yung more and more water papunta sa shore, and the higher the sea level, the more water can get basically pushed papunta sa lupa. Yan. So, lahat ng to ay direct effects ng changing climate that we are experiencing today. Right? So that's it for today. We'll continue yung discussion sa face-to-face tomorrow.